There, I'm done. Hello everyone, welcome to another live stream. Hi there. There we go. Hi the Katsi.
Yeah.
Hi. How you doing? How are your Christmas going?
I'm doing good. Are you gonna be doing tests?
Yes.
Are you a variety streamer now? What happened to the work?
Well, I am gonna be doing tests. Yes, that's gonna be my work. I don't think I'm gonna be doing tests in the way that you imagine I'm gonna be doing tests.
Oh.
Yeah. I'm gonna be...
What do you mean?
Well, I'm gonna be doing tests. I'm going to be creating tests on the website.
That's not what doing means.
That is doing tests.
No, that's making tests.
Well, I won't be making the tests themselves. I'll be doing the tests, the system for them. Hi, the skid. Why do you feel weirdly scared right now? Oh, actually, remind me, I have coffee in my fridge. I made it yesterday. Haven't had a chance to drink it yet.
Really scared? I'm sorry, I had to.
It's cold.
There's no other way.
Jesus.
Meow.
I have some iced coffee now. That's lovely. There we go. Make it. How confident are you that I can cook stuff without burning it? Very confident. I've literally seen you cook. Okay.
I think I can cook milk without burning it.
What are you cooking? Also, hi there, Amy. Jolly crimes out. Yeah, it's Cherry Mistmas. Yeah, it's Almaty made it because obviously Almaty has made. Almaty has made this within like a 2-window span from making my new favorite piece of Almaty art, which is this, which I just find ridiculous. And also while working on another thing for me, which I just think is comical, it's hilarious. But yeah. These are
She keeps on pumping. She keeps on pumping.
Check general. I'm not supposed to be seeing it. Hold on.
General?
Oh, you Minecraft. As in like glitched Minecraft? Huh. I see. I'm boiling beans, but since I'm also busy writing the last part of the Taylor expansion thing, I'm not watching. Well, listen. That means you're just cooking twice the much, so you know. Take it light. Beans are genuinely... I personally don't like beans. I find them too British. They just... Unless we're talking about Mexican food exclusively, in which case you get a pass. But... Such and henceforth. I remember, but then I forget. I'm gonna take a sip of coffee first, if you all don't mind. Because I have made myself an entire pot. It tastes disgusting. It's awful. It is genuinely... It's the same coffee as I have been drinking.
Are we back to the sewage coffee?
Well, no, not the sewage coffee. I haven't drunk the sewage coffee in a really long time. But... Actually, I haven't... No, wait, because my coffee progression... Hold on, I already have the paint open, this is beautiful. My coffee progression was actually... It used to be the sewage coffee. Then it was the chemicals coffee.
No.
I don't remember when I actually started drinking the sewage coffee. That was back in the old days.
Not the beware of the coffee pipeline.
This is the coffee pipeline. It was the sewage coffee. Then it was the chemicals coffee. Then was spun off... Well, I started drinking chemicals coffee before I moved. And I stopped drinking it after I moved again. So that was over 6 months of drinking the chemicals coffee. Which genuinely... It tasted lovely. I liked it a lot. The only reason why I stopped drinking it... is because I genuinely was concerned for my health. Considering the amount and the type of coffee, to which I started drinking. Well, that was after the 6 months. I started drinking the dissolvable kind, the standard coffee dissolvable kind. But that was for like a very brief window because then I switched to just normal coffee. There, this is my The coffee. So the cold sewage. I haven't been drinking that in a while. And yes, I used to call my coffee cold sewage, and it was not.
Oh my god, look at here. He's an icon. He's the ghost.
Oh my goodness, it really is the ghost. I had to check my Discord because it didn't show up on stream. Hold on, let me fix that real quick.
That is a lovely avatar too.
Yeah, it is. Hold on, because everyone watching the stream will think that we're crazy.
Crazy? I was crazy.
Shut up! Oh yeah, so that, by the way, it has a different reactive from the profile picture, funny enough. So if I do this, there we go. You can see. Oh, the muted symbol as well, that's funny. I wonder if I join into other people's voice chat, if their reactive is also just buff making.
Oh, they have a custom avatar. What the fuck?
Yeah, yeah. Could we consider the chance you remember as discrete to the quantum state with a sum of superpositions? Well, funny you should mention that. That's what the next video will be about. Just tune in on the 9th of January. I'm exhausted. I am. And I'm also really behind on my work. And when I say really, I mean above average. Oh, it talks.
It talks, yeah?
I had to stop myself. My instinct was to say it talks, but that scared me. Jeez. Hi, the soda. How is the jolly days going for you?
Very jolly, very jolly.
Oh, glad to hear. Glad to hear that.
Oh yes.
Thank you, Adrian, for joining in. Just to say that we look crazy. Cheers to that. I appreciate it. Yeah. Pull up the picture of Max Planck while working on quantum mechanics. You mean the progression?
That makes me wanna get a animated avatar now.
Do you want the custom avatar? I mean, you can upload it to Reactive yourself, if I'm not mistaken, actually.
Can I have a link?
Yeah, hold on. Yeah. They changed how it works, so I have no idea how it actually works.
I have an idea of what I do.
There we go. My goodness, everyone is green on my Discord. What is happening?
So jolly, so green.
Tis the jolly day! I had my Christmas ramen yesterday. I'm having my Christmas coffee today. Life is great. You know what's annoying? Banks are closed on the weekend. All the important bits are closed on the weekend. And the past...
It's also Christmas.
Yeah, the past 3 days, that's Christmas. Tomorrow is no longer Christmas. But it's a Saturday. And before Christmas... Well, first things first, I forgot to buy any groceries. That's the first thing. But more importantly, I didn't set up a bank account for the foundation.
Oh.
And which means that I couldn't do it 3 days ago because it was the Christmas Eve, and it was the first Christmas Eve of Polish history when it was a fucking holiday. Normally it wasn't in all the past years. It was this time. 2 days ago it's Christmas. Today, Christmas. I mean, I say today, but it's 2 days ago. It's supposed to be yesterday. Yesterday it was Christmas. Today it was Christmas. Tomorrow it's Saturday, so I can't do it. In 2 days it's Sunday, so I can't do it, and I'll only be able to do it on a Monday.
Yeah, did you know yesterday was the only Christmas that's on 25, 25, 25?
Yeah, I know. This is huge, isn't it? It's 25,
Yeah.
25, 25. And also
Yeah.
it's the best because then you have when the hour hits 25, 25, then it's like one of a lifetime sort of thing.
Yeah, also another curious thing. This year's New Year's Eve is on Friday the 13th. Did you know that?
Many congrats on setting up your own foundation, very big. Don't congratulate me yet because I wish I could say we're only halfway there, but we're not halfway there. It's so much fucking work! To be fair, I have gotten past all of the legal requirements and most of the organizational ones. So, the foundation is registered. It exists now. If you actually really, really badly wanted to, you could find it, I imagine. I have no idea. Still big. Well, yeah, like, that's the reason why Why I need to get to work, isn't it? I can't mess this up. The thing is,
Put my beans on boiling. We'll see if the work alarm trips or not.
very apt introduction. I actually have another reason to join it. I watched the latest video again. So much more makes more sense now. I think in 1 or 2 watches I get everything. I really hope you do, because I will admit, making the video that long was a mistake. And the fact that the sole reason why I made it that long was just because Caper said that he likes longer videos. That probably might have not been the greatest of reasons. Next one's going to be shorter. As I mentioned, 9th of January is going to be the foundation, the first foundation thing. So mark your calendars. It should be a Friday if we didn't mess up. Did we mess up? Hold on. Online calendar. Poor cows, they're all getting ended. January.
Do you need to do the thing when you do 4 fucking streams a day because you missed some?
Well, no, hold on. Actually, you know what? Glad you brought it up. Let's see how many more streams I need to make before that day. Dates calculator. Funny enough, it's the same website, but there we go. And then until the 9th of January 2026, I need to make, today's 27th, which means I need to make 3 plus 19, 22 live streams. And there are 14 days, which means, that's not quite as bad. If I stream twice a day, I'll make it. That's better. That's better than I imagined. I genuinely thought I would need to stream 3 times a day. The existence over the end. Usually you'll be happy with a very small tab, even if it's infinitesimal. Root, have you been on some kind of physics high? Because you are making a lot of physics references today. Have you been watching? Oh no, it's the video, isn't it? That does tend to happen. That's how it starts. That's how they get you. Next thing you know, we're gonna be building a particle collider. That's what. Beware of the pipeline. Just saying. Learning all the math stuff from like 5-10 years in one video is a lot. That's explaining really well. I do have to say, it is actually. We are ending that video on some pretty heavy mathematics. Once again, I do believe I could have explained that better, and I should have explained that better. I kind of messed it up. Next time I will explain it better. But what did we finish on? We finished on the quantum harmonic oscillator, didn't we? That's pretty chunky. Yeah. It was the quantum harmonic oscillator. There were some interesting things there which we did not address. The states are curious, simply because, well, it's kind of like effective. Yeah, I won't be boring you with that, come on. I mean, not boring only, it's right now I would need to give you a very surface level explanation, and this warrants something more exact. Okay. This, did we render this? This stream as well will have a lot of rendering, because a lot of my work from now on will be just rendering. So. I don't know what I'll do in the background exactly other than the coloring. I didn't think I would miss my piano because I normally haven't played it much in the past. But I genuinely had times when I wanted to just have a manic break and I couldn't. It was torture, awful. Just 13 hours and learned quantum physics, Fourier transform and Riemann zeta functions and quaternions. Jeez, that's quite a journey. Impressive, because in 13 hours not losing focus, that is really impressive, and good for you for learning about all that. That's not easy.
Yeah, very nice. Meow.
Okay, you know what, I'm going to be coding in the background, don't feel too pressured or anything, don't worry, I'll still be chatting about, we can still carry on the conversation, I just need to be doing this because otherwise it's gonna be...
doing the avatar, it's gonna look magnificent.
Oh goodness, I kind of regret giving you that power. I think I will need to update it myself on my Discord reactive.
Don't worry, it will not be anything terrible.
Well, you say that, but
No, no, you're gonna actually love. You're gonna genuinely love it. Trust me.
I will try. Is float? No. I think making a blog explaining what terms mean, what would actually abroad, like whereas it can be replaced by x dot, etc. Yeah, the notation is certainly quite annoying, simply because in mathematics you have a lot of different things which are all really similar, but the core they're slightly different, and that translates to a big difference later on. In physics, however, you just have a lot of synonyms when it comes to notation, or a lot of shorthand notation. So even with just derivatives, right, you have derivatives, you have partial derivatives, which sometimes are put in places where no derivative would suffice, but physicists just are used to partials. You have shorthand partial notation, you have the dot, obviously. Well, dot wouldn't actually work like that. It would have to be... Dot wouldn't actually work like this exactly because the dot is dependent on time. So I suppose T should have been all here. What other? Because I'm certain there are more. Hi, Remy. How you doing?
Hi.
Hi.
Hi, Amy. Hello.
Cherry Miss to you.
Cherry Miss.
Well, that reminded me. I have gotten... A good friend of mine has given me some gifts. 2 of them, to be more exact. Games on Steam. The first one was Megabonk, which we have played yesterday. It's great. And the second one is Dispatch. I have actually... I have actually received.
No.
And it's a shame because it's a game I genuinely would love to play. I really want to play it. But goodness gracious, the timing is terrible. It's so funny. She asked me when am I free? Right, when will I have some more free time? And I just stopped to think and I answered, oh yeah, August. That's when I can make some time in August. And I genuinely... Have you received 36 too? No, I have not, but I do still, if I'm not mistaken.
I think you need that. In 36 too.
Well, I think I still have 36. Yeah, I still have it installed. Don't worry, I don't need a second one. I still haven't beaten it. That game is a lot of complexity and already difficult.
Yeah, of course.
Honestly, the strategy itself... Oh, jeez. The amount of experts on probabilistic thermodynamics I've consulted just to create a good strategy for the game is immeasurable. Truly.
Yeah, of course.
Can I first...
Nothing beats for 36, obviously.
And you can quote Katsu on that! If someone could please quote Katsu right now or clip Katsu saying that would be tremendous. Would we appreciate it?
You know what? I'm going to take it. It's fine.
You know what? I am going to find coach you with that. Hold on. There we go. Ah, this is awful. It's atrocious. I'm not gonna describe the taste because that wouldn't be nice, but it does taste atrocious and I regret every sip. Alright, Flask DB upgrade. I don't ever remember which switch. Migrate. Migrate. That should do it. Alright, splendid. Make it builds weapon episode 2 would be great. I started the work on that, but then I didn't have the time to finish it. I didn't even get halfway through. I would love to, because I have, even just in my office right now, I have so many things I could turn into a weapon. Genuinely. I can make a flamethrower like that. That wouldn't even be difficult. I could knock a flamethrower down in, I don't know, 3 days. I have a vat of sulfuric acid behind. You hear this? That's a 5 liter or 6 liter vat of sulfuric acid. Oh, vat isn't the proper term. It's a glass container. I can make you a throwable rock in 3 seconds. I would be more impressed if you made an unthrowable rock, to be honest. That sounds like a lot more of an invention. Acid is not even that. I have, goodness, on my floor, simply because I haven't had the time to put it away into the chemicals closet, I have cyclohexane, I have phenol, because why not? I have one chemical that's wrapped in plastic, and I haven't actually checked with it. You know, I can actually check with this. I know we're getting distracted, but let me check. Because it's wrapped in like secure plastic that they usually do when certain chemicals are more volatile or dangerous or toxic and such. If you don't mind, I'm gonna. There's my. Oh, that smell! That's an acid. That's some kind of acid. I haven't even removed the plastic and I can smell it. That's. Before looking, I'm gonna guess. Formic acid? Might be? That would be my guess, just based on the smell alone. It definitely is some kind of acid. Oh, jeez, that smell. Oof. Time to build a laser material lying around. Reason I have the materials to build the laser. I don't think I could do it though, actually, to be completely honest. Oh, jeez. I'm regretting unpacking it. The smell is really getting to me. Second. it's wrapped in a lot of bubble wrap. Oh, jeez, what are you? Genuinely.
It's not hurt.
No, don't worry, it's just a smell. You know formic acid, Emmy? Have you smelled it?
No, I haven't.
It smells like competitive vinegar. Yeah. What is this?
Competitive vinegar.
Acetic acid! Right, that makes sense. That explains the smell. It's acetic acid. Yeah, I knew 99.5%. I knew it was acid. I can smell acid. Everyone can smell acid. Disgusting! Bury it in packing peanuts.
Yeah, that stuff smells a lot. We also have it in the lab.
Oh my goodness.
How do you like my new thing? Make it.
I didn't even know they could be animated, but that is
Is that good?
that is phenomenal. That is pretty good, actually. I did not, in fact, know they could be animated. Oh, damn it!
Now you know.
Now I'm tempted to animate my make it
Oh.
because I really could. I had coffee. That coffee doesn't taste so bad now after I smelled that. To be honest. It actually smells pretty good. Live make it doing smelling salts. Well, I'm halfway there, I suppose. That's a chemist. That's an inorganic chemistry joke for all of you inorganic chemists out there. That was disgusting. Okay. That feels like a distraction, but I'm genuinely tempted to animate my make it right now. Because
I've successfully distracted you.
well, don't yet, not yet. Don't pat this on the back just yet.
And now I wanna keep speaking to see the thing go.
Those chemists will be inorganic by the time I'm done with them. Goodness gracious.
No.
We really are missing some organic. We have been for a really long time, but we're missing some organic chemists, experts here. The sole reason why I've even delved into chemistry in any way that I have is because of Flame. And I imagine if on the server we had just like we have Remco for physics, Flame for chemistry, if we had like an organic chemist, like a biochemist also, I would be a lot more into biochemistry and organic chemistry. We need to find them. I know they're hiding around here somewhere. We're gonna find them. Oh,
Yeah, of course.
my goodness, this coffee actually tastes pretty good after that. If you think your coffee is terrible, just sniff some acetic acid. Or any acid of any kind, I suppose. Any of the organic ones. The organic ones are terrible. The inorganic ones can be painful, have high concentrations, but I've always found their scent to be tolerable. Oh, formic acid was awful. I remember when I was making the glowing stuff, the fluorescent materials. It's honestly incredible just how violent a smell can get. It's the same as when you're eating like spicy peppers, but instead of taste, it's a smell. It's incredible. Right, I was enough talking about smells. Animation. You won't believe it, but I'm genuinely addicted to the smell of beans as they cook. Do beans even have a smell? Ash, you're not gonna rope me in with beans. I don't enjoy beans. I find beans to be... Go on.
Yeah, beans are British food. I don't know why the fuck you eat it. Evil fucking breakfast. Emmy, you know what you should have?
What?
Should have your animal to be the pat give. Emmy pat.
Shut up. Maybe.
We're all gonna turn our Discord reactives into animated ones just for the show. I genuinely didn't know that. I'm so glad you changed her to animated because that might improve things.
Have you smelled aniline? That smells really bad. It kind of smells like ammonia, but more fishy.
Oh, jeez! I was expecting you to end at more. I wasn't expecting you to carry over with fishy.
Fishy ammonia sounds like the worst thing ever. What the fuck? That must be so bad.
Yeah, it was. We were working with that in the lab one
The-
time, and the whole lab smelled.
The worst thing I've ever smelled is a Thai, because formic acid does have a pretty atrocious smell. However, it's not really the smell itself, more as an experience. Earlier on in my YouTube, let's be charitable and call it a career, I had a point where I made a new Make-It mask, and I needed it for a recording. However, I just finished making it, and the see-through, like, one-sided mirror things in the eyes, the glue hasn't really dried properly. And it
God.
was the cyanide acrylic glue. So, it's basically cyanide.
Oh my god.
And so I
No.
just put it on for a recording. It is honestly, I can't really describe it well, other than it was painful. It was genuinely just painful. It's not like some glue got on my face or anything. It's just the like aura around it, and having that inside of a mask that you're wearing
You
was
are
awful.
insane to be like, let me just casually put cyanide in my eyes.
Well, it wasn't cyanide. It was the glue that's based on cyanide.
So it was basically cyanide. Okay,
Is it
yeah,
cyanide acrylic? Because I don't want to be out here lying either. Cyanide acrylic. I do believe it's cyanoacrylate. Yes.
Okay, I'm back.
Welcome back.
I'm back.
Everyone.
We are on the trend of making animated profiles now. If you look at my beauty in the stream,
Unfortunately, I'm not skilled enough to make animations, and I'm too lazy to grab one off the internet. So
oh, what the fuck? How could you?
I am going to actually partake in. First, jeez, why am I having such a hard time focusing?
Okay, I gotta go again. I have a tight schedule. Bye
It's
bye.
fine. Bye. Have a good one, Emmy.
Bye.
See ya.
You too. Bye bye. You're cool. Bye.
Brilliant way to leave. Also have to go. Alright, so that Cherry Miss, have a good one. May your
Merry Christmas.
Merry Crisis. Adios indeed. Alright, refresh, there we go. Okay, make it good together. First, I need to finish this, and then I can scrub out. Oh no, this can go right here. And then start and end like this. However, we don't want the start to be right there. Only we want the first one to be one. No, one. 0. Single horizontal. Oh, jeez. Right. This. But then the height has to be. Oh, fuck. There we go. Now let's make an animated, make it. Where is my make it? My make it is obviously right here. Which one of these is the? No, that's the American. This one is the strong make it. This one is the yeah. There we go. When you stand up, then you have the cap one. You can also have this one. What happened to your hand, buddy? What is up with that? We gotta fix this. There we go. Is that the same as in the current model? How long have you had your broken fingers for? Well, there's gonna be some chat and make it. Fun fact, just like how most gamblers quit the road before they being away, most mathematicians die before finding the zeros of Riemann zeta function. Never give up, kids. Make it, have I told you my daily routine yet? I don't think you have. I think I have very good news I just randomly remembered. What is the good news? Do tell them. Actually, Ash, I have a question.
Do go on.
What is your intuition? How good is your intuition on matrix multiplication?
I'd say it has to be pretty fucking solid at this point.
Because I'll be honest, I know how matrix multiplication works, but I don't have a good intuition for it. Every single time, it takes like conscious effort to remind myself how they work.
Do you mean as in what matrix multiplication is doing, or the algebraic computation?
Well, the computation I know, but I don't like understand why it is the way it is. If you get what I mean.
Yeah, I do. Essentially, the idea is that a matrix represents a map between two vector spaces, right?
Yeah.
And what each row or each column, I always mix up the row and column, but um, one of them, let's say the column, right? The column tells you um, in your image vector space, um, what combination of vectors, what combination of pre-image vectors give you that thing.
Right.
Okay, so yeah, so you wrote down the matrix A, B, C, D, right?
Yeah.
So this is going to be a what's it called? This is going to be a map from R2 to R2,
Right.
right? So it's going to, so your basis for the general R2, let's consider it to be 0, 1 and 1, 0, right? These are your
Yeah.
two basis vectors. So it just tells you this map, what this map is telling you is that um in your image space, right? Your first basis vector is going to be A times your first basis vector, which is 1, 0, plus B times your second basis vector, which is 0, 1, right? So it's essentially just telling you, like, in your image vector space, what combination of vectors is it in the pre-image subspace? Like, how do you combine your vectors in the pre-image to have your vectors in the image?
Okay.
Yeah, and see, this is going to be one of your vectors in the image space.
When you say image space, what does that mean?
Uh, Image space means, okay, so you have your pre-image space, which is the domain, which is
Oh, so
the
this
domain.
is the pre-image. This is the image.
Uh, your stream is a bit behind, but I think you have the right idea.
Well, I mean, there are only two R2s, so I can.
Yeah.
I feel like I can make a pretty solid guess on which one is pre-image and which one is image.
Yeah, yeah. Okay, you have that.
I can make a Discord stream.
No, it's fine. I got it.
Yeah, but okay, so. Oh, I mean. What confuses me is when you have a matrix multiplication between two matrices, so something like. I'm gonna represent them with dot because, well, I don't feel like drawing them. When you have, for example, a 3 by 3 matrix multiplied by
Yes.
a 2 by 4.
Oh, that's not possible.
Is it not? Oh yeah, right, because the diagonals have to. So it's gonna be 3 by 4 multiplied by a. Wait, 3 by 4 multiplied by a 4 by 2. That is possible, right?
Yes, that's possible.
Yeah, like for example, in this case, that breaks down for me completely. And even worse, another thing which I suppose would be an even better thing, but I imagine matrix multiplication should come first, which is tensor multiplication, because if I recall correctly, tensor multiplication is just generalized matrix multiplication, isn't it?
Um,
Is it not really?
no, it might be, but like you can't just
Okay.
say it's a generalized multiplication and expect it to be like true. There are some
Well,
okay, let me
when I
think.
say generalized, I mean that if you consider matrices to be tensors, then tensors of like lower order, then it should still hold, right? I mean, I genuinely don't know. Oh, it has the question mark.
Um, the thing with tensors is like it's not. I don't think you have the same idea of like generalized multiplication that I do, because the entire idea with tensors is you want bilinearity, right? So let's say that you tensor. So you have what do you have here? You have a shit. It's row by column. Yeah, you have a 3 by 4 and a 4 by 2 here, right?
Mm-hmm.
Okay, so below them, just to annotate it, write that this is a map from, yeah, okay, 3 times 4, 4 times 3, right? So if you take the tensor product of these two matrices, what you're essentially saying is that you have a map from, let me think about this, R4, write this down, R4 tensor product R2, To R3 tensor product R4. Is what the tensor of two matrices means. Because what you're doing is like the tensor is symmetric, right? So it doesn't matter if you do it like if it's AB or BA, it's commutative essentially. So when you take the tensor product, what you're doing is you have two different spaces and you don't want them to be like fully connected with each other. You want them to be linear, each in their own right. So you act on them with like two different matrices, one on the first component and with the second matrix on the second portion of the tensor product. And that gives you like two different maps that you can each apply separately to each thing.
Okay, this ain't gonna work in this fashion. I've bitten off way too much than I can chew. We would need to take it dedicated and slowly. First of all, do you even have time for that sort of thing right now? To explain the intuition
Yeah,
from...
my beans are boiling. I have like 2 hours, so
Okay, that's some pretty hefty beans. Alright, in that case, another thing, I will every now and then need a little bit of break, like right now, to set up the next animation to render. And
yeah, no problem.
because the thing is, I feel like this is one of the sections I'm really lacking in. I have a really, really good intuition for dimensions. Really, really good one, but it's being really held back by the fact that I have such a poor intuition for matrix multiplication. And
Yeah, it's fine. Matrix multiplication, believe it or not, it took me all the way till I generalized to infinite dimensions for me to get comfortable with it.
yeah, but you know, I am... Yeah, but the thing is, I come from computer science where you basically, I come from low level computer science where it basically takes you years before you apply a dimension in a spatial dimension context. Like normally you treat dimensions in terms of just independent variables. That's how you treat them for most of the time before you... The only time you actually treat them in the spatial kind of way is either in the classical where you get to simulations and engines, or when you get to like similarity with distance functions where maps in n-dimensional spaces, or you have n-dimensional spaces and things that are close together have some kind of meaning. But what have I messed up here? Right, I haven't plugged in this. This is good, but then both of these need to be subtracted. Yes. Two? No. Why is this angled? Why are you halfway at the halfway point? That's a problem. Multiplied by 2. Not, yeah, fine, solution. Okay, in that case. Wait, Katsi, I'm really sorry for shutting up the conversation. If you want, we can move on to a different topic.
No, it's okay. I don't mind. I can just do whatever the fuck in the background.
Alright, if you say so. In that case, do you have access to the whiteboard, Ash?
Let me check real quick. Not currently. I might
Free
need
Blue and Brown
to-
has a very good video on how to think of it in terms of basis vectors. Root, I don't mean to be that guy, but I have a really good video how to think of it in terms of basis vectors. The only problem is that I am not satisfied with the intuition. There we go.
As it turns, that turns the whiteboard.
Give me a second then. Alright, here, have that. This, does this give you the access? Also
Yes,
here,
that
have Katsi,
does
so I don't have to throw you every single time. There we go.
Oh my god, my Discord is so laggy. Hold on.
What? Oh, what even is this whiteboard? I don't remember this one. But this looks like an I have vague memory
Okay.
of this whiteboard. I don't remember from where. Oh yeah, this was for when I was asking about differences between partial derivatives and normal derivatives. What is this A, B thing
Oh
at
yeah,
the top?
yeah.
Where's that? Why is it 8,
have no
9,
idea.
10, 11?
I don't think I will see that. Probably both trying to take it away soon.
Oh, this is, what did you say, Cassie?
That probably both is gonna take that rule away. I don't think that's gonna stick.
We'll see. But... okay, splendid. In that case, in any way, any case, any such... Oh, this was for the RFID card, I remember now, I think. I'm like semi... You know what, doesn't matter. The point is, let's start small. Right. Let's start, and I don't know if this would be too small, but I would like to generalize a bit. So this could be too small, but I would like to start with R1 to R1, if we may.
Yeah, sure. That's perfect.
Okay, so this would be just, well, first, maybe, if we could we do it in sections first, matrix transform, then bracket, then matrix multiplication? If you get what I mean. I know that they're not different, but what I mean is that this... It's gonna be idiotic because it's R1, so all of them will be the same here. But, you know, first it's gonna be a matrix by a vector, then vector by a covector, and then matrix by a matrix. Like that.
Yeah, that's hilarious in R1 because
All of them are the same thing! Hi, Dual Matter! Hi! See, it's still jolly. Yes, it is! It is in fact jolly. I just hope that your signature is visible. I'm really sorry. I will be honest, it is a bit awkward and it is constantly getting in the way, but I am determined. I'm going to keep it for the entirety of Jolly Days. I just hope that your signature is big enough. Okay.
Signature?
You use the tone that you normally use when you're making a joke, but genuinely cannot find it. Oh, signature, shut up.
What? Did I make a joke?
Yeah, you're doing it on autopilot now. You didn't even realize it.
You
use the
I
signature.
actually didn't see the.
You use.
No, I didn't see the art because I had it covered by like some window, so I was genuinely confused. I'm sorry.
No, you said signature in the tone when you normally say signature. I barely know it.
But doesn't make any sense.
You said it. What do you mean? I am not
I
the one.
wasn't. Whatever.
Genuinely,
I barely know her anyway.
rewind the live stream and see that you said signature in the tone that you always use when making that specific joke.
It's just a tone of questioning things. It's not like a. The tone isn't a result of just the joke.
That tone is very much. You will see.
What do you mean? It isn't the tone specific to that one joke. It's just a questioning tone.
Oh, shut up, Ash. Right. AB. It doesn't matter. AB. AB will just be AB, won't it? Right?
yes.
Okay, good.
That is-
Maybe. I barely know her.
Does the... You know what? I feel like we should start smaller in that case because this is a bit rough.
The thing is, any map from R1 to R1 is just scalar multiplication. There exist no other maps.
But that's it.
because you can have like any number squared because that would break linearity. You cannot have plus something because that would shift the origin and that would make stuff break. So the only allowed thing is just scalars in R1.
I did get ignored. Skid, I just don't know how to react to that. I'll be brutally honest with you. the way you write B is of the devil. That's how I was brought up to write B this way. Right, R2, R2. So for R2, R2, it's gonna be A, B, C, D. Oh, that's gonna require a whole. I don't even know if there are that many letters in the English alphabet. D, E,
F, G, H.
F, like this. Then it's going to be A, B, C, D. Thank you for thank you thank you so much for that clue, just in case I forgot. Cheers. I do in fact remember at least 4 letters of the English alphabet. B, C,
That's
D.
good. Wouldn't want you to switch into like Polish letters or something. I don't know.
Yeah, Polish letters.
Yeah, the Zinc letter. Oh, that's my favorite.
What?
Yeah, the Zinc letter, you know, the Zinc letter of the Polish alphabet, the one that's written down like this. Wait, and then right here is a line in the middle.
What the fuck is that?
The Zinc letter is in between the M and N. It's M Zinc N.
Yeah, the Jink letter, of course.
Yeah.
Polish.
So for example,
Can I
you
refer-
have a plum. When the word for a plum is Zinke, so it's the Zinc letter,
Yeah,
and
Jink.
then Zinke. That's the word for a plum. There, you're learning Polish. All right, doesn't matter. Ash, let's get back to the
Yeah.
lesson. Right. So basically,
I'm
right.
so happy there aren't any Polish spelling chat right now.
Well, I mean, they would tell you about the Zinke. Yeah, it's pretty common.
I mean, yeah, of course they know.
They know about the Zinke.
Yeah.
I'm honestly surprised that the English doesn't have a Zinke. That's such a. It's used so. Honestly, my name is spelled with. It starts actually as the
Yeah.
first letter of my name. It's Zinke.
Drink it. Anyway, yes. Are we writing out the expressions for these or?
Well,
It is unkind how it's real.
well. The intuition is more important right now to me than the equation. So let's first talk about it.
Yeah.
The way I understand this is that the was it? I never remember if it's columns or rows though. It's rows, right? Because then the covector make right. Goodness, no, it's
This
columns.
is a row. Columns is vertical.
Yeah,
This
I
is-
know that.
Oh, then what are you asking?
I am asking
Really?
because what I was half thought because I wasn't certain if the thing I was referring to was column or row. When it comes, the way I understand it is that these define the new basis vectors that are applied to this vector. But I wasn't certain if the basis vectors are defined in columns or rows.
Yeah.
I swear, Ash, you have that thing where you like gloss over the most difficult and unbearable to understand concepts, and then you feel the need to remind me what letter of the alphabet comes after D, and what is a column and what is a row. The priorities are out of whack here.
Oh my god, I don't know. I'm autistic or something probably. Anyways.
Okay, so
Yeah.
I think it was columns, right, that defined the new basis vectors.
Yes, I believe so.
Right, so that's my understanding of a matrix transform. I swear, I thought you were spelling alcohol in the ABCD, mate. Muscle memory, I don't know what to tell you. Anyway, so the way I understand it is vector. Okay, but I need some kind of better intuition for it, not understanding. That's what we're looking for here. So this vector, we're just changing the vector space. That's what the matrix transform is doing. It's changing the vector space of the vectors. That right now what we get out is a new vector that's yeah, fine, let's not know, GH, whatever. Or should I? Maybe I should just, yeah, no, fine, GH, whatever. So this, what matrix transform is doing is basically like an EF equivalent in the ABCD vector space. right?
ABCDs.
So we have I don't know how to note down the vector spaces. Just capital V.
Yeah.
Let's do V naught and let's do V1, V prime. Doesn't matter. Or actually no, V and V prime. That's gonna be clearer. V prime. We're going like this, and what this thing right here is doing is you're taking an EF vector and you are creating its equivalence in the V prime vector space. What I mean when I say equivalence is I mean if you transform the underlying vector space and take the vector with it, that's where the new vector will lie. Does that make sense?
Yeah. That does make sense. Yes.
Okay, so that would be the intuition for the matrix. Matrix transform is the one I know the best because, well, I've made videos about it and I use it in Blender.
Yeah.
That's simple. Then we get to the covector vector case.
Yes.
And for this, I don't have an intuition, or at least not a good
Oh.
one. The only one I have is from physics bracket, where this is just where you have to remember that the way I learned quantum mechanics was I started with the wave function complex conjugate wave function, and then I went from here to the vector covector, which means I understand the vector covector as like getting the magnitude of the vectors combined together. But in order to that, you need to think of this as a vector as well.
Okay. Could you for 1 second hold that thought? I don't hear my stuff anymore, and so
All right, go on. It's fine. I'm gonna check up on the the animation finish rendering. How lovely.
Oh no, not the beans.
Flip the horizontal into a space into a dot product. I know root. Root. I am perfectly aware. Don't you worry. What we're looking for here is we're not looking for the computation. We're looking for the intuition. We get vertical divided by horizontal tensor slopes. So right here, this.
Okay, I'm back. Okay, so covectors. Really simple. Okay. So essentially, since we're in finite dimensions, that's gonna make things really easy, actually. We have a vector space, or okay, let's just say 2, right?
You can make the pen smaller by dragging the circle on the.
Oh, I can.
Yeah.
Technologia.
Oh, get out of here! Jeez, I prefer math brain root to this.
Okay. So we have R2, right?
Mm-hmm.
And okay, so R is basically a field that generates the vector space. What does that mean? That means that if you have any two vectors, right?
Mm-hmm.
A, B, in the standard basis, you can write it as A times, sorry, not this one. A times 0, 1.
Right, basis vectors multiplied
Plus-
by the magnitude.
Yeah, okay, exactly. And A and B are members of the field R. They're real numbers. That's all they are, scalars,
Right.
right? And in complex numbers, A and B could be complex numbers, and so on and so forth, essentially. So with covectors, what you're essentially aiming for is that you want a map from your vector space back into the field you're in. So in our case, that would be R, right? And now what is this doing? One way you can imagine it is to every single vector in your vector space, it's assigning a number, it's assigning a scale, right?
Yeah.
But it also has to obey like the what we call it. It also has to be a linear map, right? It can't just be any map from R2 to R. It has to be a linear map, right? And then this immediately puts some constraints on what a covector can be, right? So if we'll just write it in terms of maps for now, and I'll clear up the covector terminology in a second. We have a map that's going to act on a vector, right? And it's going to produce some scalar.
Right.
Okay. Now our vector EV, it can be written as E of some A E1 plus B E2. right? Just in terms of our basis vectors, if we let this be V,
Yeah.
so it can just be broken down into combinations of basis vectors. And then this, since our map has to be linear, right? This simplifies further into A times T E1 plus B times T, oh sorry, there's no bracket there, plus B times T E2. Ooh, damn it. 2. There we go. Do you follow algebraically what happened here?
Yeah, I mean, that's trivial.
Okay, nice. So essentially, that is all that a covector is. Like a covector, you can think of it as a vector, yes, but in general, the way that you should think of it, in my opinion, is that it's essentially just a map that assigns a scalar to all of your vectors in your vector space linearly, right? But you can see that we have written here everything in terms of maps, right?
Yeah.
So how is this a vector? Well, the answer is really simple. Because we're in finite dimensions, so you might know from your matrix multiplication thing that what a matrix does to a vector, right? What some matrix does to a vector, like BF or whatever.
What I may MF does to a vector.
You can tell that exactly if you just look at what the matrix does to the basis vectors, right? If you see how the basis vectors transform, you know how a general vector transforms, right? You have that intuition.
Yeah.
Yeah, okay, perfect. So what the covector is it's nothing but a map from a vector space, right, to another vector space. And funny thing, since this is also linear, you can just, and it's like a proper linear map and everything, you can characterize this map entirely by looking at what it does to these basis vectors, right?
Okay, maybe on that. Carry on for now.
Yeah, okay. So you can characterize a covector or a linear map from Rn to R entirely by what it does to your basis vectors. So if I just compute T of E1, right, and I compute T of E2, right, these are the only two things I need to characterize this linear map. These are the only two things that I need to characterize these linear maps. And they could be any scalar, right? And they're an element of R. And what's more is they're also independent of each other, right? And because of these properties, it turns out that when you identify a map by its action on a basis vector or its action on a basis like this, then it turns out that it's just isomorphic to, in our case, R2, or more generally, Rn. But you just generally, it's called a covector because it acts on a vector. Like you can't have a vector acting on a vector, you have a covector that acts on a vector. It's just terminology. So
Okay, first I do have to say I think you lost me around this point. But
Okay.
before we go on, I should maybe specify my confusion because I'm thinking of it in terms of like, unfortunately that's a pretty poor habit of mine, which is I think about most mathematics through the lens of computer science because, well, that's where I applied it most. So
yeah, okay.
from my perspective, it looks like this: you have an object which is a vector, right?
Yes.
Vector which is in the field, right? Let's say R2 once again. Now, applying a covector onto this object, I imagine as like a transform of just another vector. So we have v0 and v1, and this transform would be then the adjoint. That's how I see it. That's why like my intuition for covectors is that there's adjoint vectors. And like everything dual related loses me for that reason.
The
Because
thing is, like,
I can dual vector space to me. Is that even a thing, dual vector space?
yes, they are a thing.
Yeah, well then in that case I don't understand well it's that to me a dual vector space is just a vector space where each vector is just an adjoint.
The thing is, like, what you're saying is, it has a lot of caveats in it. It's not immediately true. Because, for example, one thing is like, it's only this definition only exists once you have a basis on your vector space. Without a basis, you can't even define the adjoint operation, because like you don't. It's you need to have a basis to adjoint it, essentially.
Do elaborate on that.
So that's one
Maybe
thing.
leave
But
an
like,
example. Wait, hold on. Rude just
but
said,
we can.
can we appreciate how insane this is? That this is equal to an of product. The intuition you're learning right now is fundamental identity of quantum mechanics. I'm saying it because it's insane. What? Okay, hold on, Rude. What intuition are you talking about? Because that's a problem. I don't see the intuition. That is the entire problem I'm having. I know what a dual vector is. Covector, dual vector. Jeez, you have. That's my. I'm putting my formal complaint to the maths department, which is too many things. Dual and co.
And also, another pretty important caveat is that, okay, you're a fucking physicist, so this doesn't apply to you, but in general, if you have a vector, right,
Right.
you don't immediately have its dual space, right? If you have a vector space, then its dual space is not identifiable with the original vector space. In case of Hilbert spaces, it is. Hilbert spaces are very nice spaces. They have this property even in infinite dimensions, but general vector spaces don't have this property. So that's also a caveat. And so that's why when you think of a vector space, so like if you have W
Mm-hmm.
in the dual of a vector space, right?
Right.
That's a horrible sign. I don't know.
Close enough.
But if
Yeah.
you have this, what you should think of it is that W is something that takes a vector V. So it's basically a map from V to R. Right? So, and the way it works is you have W.
This messes with me
Um,
for one reason, though. I think I finally get why this messes with me. Can you?
Yes.
So you have omega in this case, right? Or is that a W? Doesn't matter.
It's supposed to be a W.
Alright, W
Yeah.
then, doesn't matter. If you have a W, what happens when you multiply a W with a matrix?
W with the matrix.
Yeah.
Okay.
Because
So
if
first of
W
all-
is defined as a map, then that's where you lose me.
Yeah. No, this makes sense. But it makes sense, but you have to be careful with it. So again, W, focus on this definition, right? So W is a map from a vector space V to R. So if, okay, V is a bit too general for our case. Can I delete this somehow? It's gonna be a map from some Rn to R. Right. And now you're saying that you want W times a matrix. Define matrix, like between what vector space is the map? You can just choose anything, or I can choose for you, doesn't matter.
You can choose, it's fine.
Okay. I will just say that it's a map from Rm to Rn.
And this has to be Rn, right? Because otherwise we wouldn't be able
This
to
has to be
multiply.
Rn, yes,
Yes, okay,
because
good.
otherwise W can't act on it.
Yeah.
And then when you're writing Wm, right? If you want to write this, if you want to be pedantic, which I think you should in this case, and you want to write it as a proper map, then you should write it like this, where this is the composition symbol between two maps, right?
Mhm.
And what you're doing is, first you're applying the map from Rm to Rn, and then you're going from Rn to R. So essentially, W after M
Oh,
is going to be a map from Rm.
so like a map to a map,
Yeah. No, 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 no. It's not a map to a map.
or map through a map,
It's not a
maybe.
map.
Oh no, wait, that's
It's
not it
a
either. Uh, it's when I say map to a map, I don't mean like from a map to a map. I mean like you have a map.
It's a bridge. You can think of it as a
Yeah.
bridge. M is a bridge from Rm to Rn, and then you have a bridge from omega Rn to R. Yeah,
So,
exactly, exactly. Yeah, that's correct.
which
That is
M and then omega. Oh, hold on. I think
yes. This is exactly correct, and this is
so.
exactly
When you do matrix multiplication, that's just you just
chaining together
chaining.
maps.
Oh my goodness, that is brilliant.
Yes.
Very important commutation.
Commutation? No, it doesn't commute. The maps
That's
don't
I
necessarily have
expected.
to commute.
In which case, the order obviously matters. So, so V. What I'm about to write down probably isn't even possible, but whatever. V omega M not equal to omega mv. I don't
Yes,
think this is possible. Or maybe
Yeah,
it
this
is.
isn't even possible because with maps you really have to look at the domain and ranges. You can't just
Okay.
dilly-dally like.
Yeah.
Yeah.
But the point is commutation, or even more specifically, maybe omega m n, and using n for this as structure of whatever v is not equal, may not be equal to omega n m v, where n and m are matrices.
Yes, that's correct.
Okay, that is good. Oh, I thank you, because that is, I think, genuinely not what I've been looking for.
Yay, I'm happy then.
Yeah, that is. There's only one tricky bit though,
Do go on.
which is, or maybe it's not quite as tricky. Matrix as in Rm to Rn.
Yes.
In this case, I'm not thinking about it enough like a mathematician because the question might be a bit silly. But in this case, M will just be the amount of things inside the matrix. So A, B, C, D is 4, right?
What? This is no?
No? Oh no, this would be 2 to 2, right. This would be 2
Yeah,
to
this
2. And then is the amount of rows versus the amount of columns.
Yeah.
Okay, that makes right. Yeah. Amount rows to columns. I can tell you, I am a bit upset about one thing. Because now I see how this doesn't quite as cleanly generalize into tensors. Which
Yeah.
is a pickle. I can tell you why I wanted this, by the way.
I mean that's fine.
Remember
For a video.
remember when I mentioned that I've been inspired to some maths? There is
Yeah.
a certain thing I want to do. I don't want to reveal too much about it because I am honestly, unless I want to do it for fun, and I know that the idea won't go anywhere still. An old like pet project of mine, the hyperoperational mathematics. I wanted to combine the hyperoperational mathematics with tensors effectively to create like where basically you have concept of a hyperoperation, which is just defined like x is x2, and this is, and or more specifically, hold on,
What is this?
xn is just the amount of arrows, is equal to x up arrow n plus 1 up arrow 2, there we go, and then x down arrow n down arrow 2 is equal to... hold on. I don't want to mess this up, but I'm pretty certain I might be.
Make it, you're just writing symbols to me. I don't understand what's happening. X plus X 2X, yeah. X times X squared, okay.
Ad infinitum.
Okay. Tetration. Oh, what the fuck? So arrow is the one that comes after this?
This n just notes the amount of arrows. So you would note it down like this.
Okay. Yes.
But the thing is that with this, I don't want don't want to define up arrow exactly as addition. Only what I would like to do ideally is I would like to make it in a way so that so the hyperoperation of sigma is pi. What? I don't know what that is even supposed to mean. Hyperoperation of sigma is pi.
Yeah, I have no idea.
But because I haven't defined a sigma, nor have I defined a pi, but
Yeah.
but the two crucial bits sum the product. Oh, you mean like this? No, because sum and product in this case, they're indexed. They refer to an indexed operation, and with indexed operations, it behaves bit different. Each operation is a hyperoperation. The thing is, the two crucial changes I want to make to this is, first of all, I don't want the base hyperoperation to be addition, simply because there are certain ways you can define a hyperoperation so it preserves the identity. So basically there is a way to define it where you can do it like this. Of the identity is, I don't remember how I used to note down the fixed point. I think it was h hat, if I'm not mistaken. Or maybe it was, oh no, it was f hat, right? Like this, where f is a fixed point. No, not the identity, I'm an idiot, sorry. It was fixed point is equal to x, and then there was also a way to do it, I don't remember if they are exactly mutually exclusive, where down operated on itself is the fixed point. And that this fixed point is constant across all operations, which doesn't happen normally, because normally x plus 0 is x, but x times 1 is x. So with addition and multiplication doesn't work, because it is 0 for every single operation except addition. Now it's 1 for every operation except addition. If that makes sense.
So you're trying to just make an operation so that the identities are the same in both multiple.
Oh no, that's easy. That's easy.
But isn't there always going to be some number that fucks the thing?
Actually, no.
Like the case always with maths.
Actually, no. This is easy. There's a way to define it. If I remember correctly, jeez, off the top of my head. I don't remember off the top of my head, but I remember it was really easy to define it, where especially every single one of them was just 0. That was really easy. The bigger, like all of the things to do with it are easy. The problem is that I've gotten to a bit of a dead end last time I did that, which was 2 years ago, something-ish, I don't remember. And what I was trying to do, which I really like the idea of, was omega was basically supposed to be a set. When you start with x, then omega xn was supposed to be a set of all the numbers you can reach using nth order operation. So for addition, if you start with x as an integer, then...
Yes, I understand.
Well, no, sorry, 0, that's the first one, that's incrementation. Then that will be all integers. 1 would also be integers. Then it will be rationals, then will be certain irrationals, because we also have roots. And like, ideally, to prove or disprove the fact that giving a sufficiently high n, you could reach any real number. That would have been nice to prove or disprove. But, well, alas, my math skills aren't that good. However, So I thought that this time I could take a bit of a different approach, and instead try to go in the direction of tensors, which means try to go in the direction of, because in linear algebra, as you turn a vector into a matrix, the rows and columns are different. So that same kind of idea, except without the limit. Try to generalize the amount of dimensions of a matrix, if that makes sense. Hence why I was looking into tensors.
Wait. I disconnected because my internet disconnected. I'm gonna have you to repeat everything you said in the last minute.
Last entire minute.
Yeah, unfortunately.
The omega. All right. Well, the omega, because I remember you replying then. Basically.
Yeah.
Basically, the thing I wanted. Not wanted it because I knew I couldn't do it. But ideally, the thing that I would have liked to be proven or disproven is when you have an omega, that given
Yes.
a sufficiently high n, you can reach any number, any real number. That would have been the nice thing to prove or disprove.
If you have omega, you can reach any number for a sufficiently high n.
Yes.
Like how do you define
so-
reaching? What is omega?
Well, omega is basically, as I mentioned, omega, once again, 2 years ago, you have to cut me some slack, but xn is in omega, when writing is do zn, because z is some kind of number that you start with, where, hold on, I'm stuck.
No problem. Yeah, it's fine.
It was basically where omega is, actually no, let's do n of x n minus 1 in omega n minus 1 x n minus 1, and then right here is going to be, I'm going to use these arrows for any kind of operation, so because there are actually 4 different kinds of operations you can have, all defined based on the up operator. Just you can swap all of these around, right? So multiplication, division, in higher order you have powers, logarithms, roots, right? And there's 4 of them, if I recall correctly. So n, and then I'm gonna use y, because why not? N minus 1. I suppose in that case I should also do y, n minus 1 is equal to z n, and then z n is in omega n. So all the numbers you can reach using the hyper operation of nth order, all the numbers you can reach based on the values in the previous set.
No, I don't think for real numbers this is possible. For rationals it is, for
Well,
reals it probably isn't.
That's the thing, right? Because that's why I said I imagine it wouldn't be, because well, you have transcendentals, right?
Yes, exactly. That's
But
that's
at the
exactly
same time, it does get. But at the same time, I've never seen anyone go into like tetration or anti-operation of tetration, because why the fuck would you? But you get the curiosity for it, right? Which is that omega 0 and 1 would just be equivalent to z. Then omega 2 would be equivalent to q. Wait, q is rationals, right?
Yes.
What is it, irrationals?
No, Q is rationals. Q prime is irrational.
Well, yeah, then in that case, omega 3 would be q prime. I'm pretty certain it would be q prime.
Yeah. No, it would.
I'm not certain it would be.
No. It won't be Q prime. It would just be transcendentals. So.
No, it wouldn't be
Sorry, not
transcendentals.
transcendentals. What is the opposite of transcendentals? Algebraic numbers, I think.
Oh, algebraic, right.
Just denoted by A or something. It's fine.
In that case, we're gonna do a fancy A. Duh.
Yeah.
And the point is that, well, it would
And
have
the
been.
point is,
It would have been nice
there-
because I do imagine that the answer is most likely no, which is you can't,
Yeah.
because well, it's transcendentals obviously. But if there was, then that would mean that you could actually denote pi with just an equation.
Yeah, some function on. Yeah, that would be actually pretty nice. But
But the answer is, I imagine no. The only issue is I can't prove that it's not, because I lack the skills.
well, okay. With all the current known operations, basically, addition, subtraction, multiplication, division, and square roots, it's in fact impossible.
I
That's
know.
given by, yeah.
I know that it is
Um,
proven to be impossible.
Yeah,
But
I don't know for a general operator though, like you would have to somehow, that would be a crazy proof to read actually. If for a general operator it's proven that you can't actually bridge over to the transcendentals.
yeah, but the nice thing here is that the whole point of hyperoperations would be that you don't define the base hyperoperation, you define how they evolve. You define how to get higher bases, right? So the definition of a hyperoperator would be this, or even you don't even
Actually,
need
you
it
know
with a
what?
tool. No, like, actually,
After thinking about it for another second, I've concluded it's impossible.
yeah, I figured.
Because algebraic numbers is a countable set, the transcendentals are uncountable, I'm pretty sure. And if you have a map from a countable to an uncountable set, then it can't be one-to-one. Do we want it to be one-to-one actually?
What? It doesn't have to be one to one, because it could be any combinations of hyperoperations. Could it not?
No. If it's that would be a huge problem if it's not one-to-one. Because if it's not one-to-one, that would mean that two transcendental numbers have the same representation in algebraic numbers. So what you're essentially saying that your whatever combination of operations you have on algebraic numbers, they're equal to two distinct transcendental numbers, and
No,
that's not what we want. We want
the other way around.
No. It won't be the other way around. It would mean
Wait,
that
but it
two
would.
transcendental.
Wait, are you certain? Because right here, for example, it is not a one-to-one correlation between Q and Z, but you can represent a single value in Z with infinitely many values in Q.
No, it's equal up to a quotient isomorphism. The problem is not the thing is like one Q has many representations in Z, right?
No, well,
That's not a problem.
no. Wait, what do you mean one Q has many representations in Z? Could you give me an example?
Yeah, so 1 over 2, right? That's an irrational number. It has the representation 1 over 2, 2 over 4, 3 over 6, right? That's what
But
I
what do
mean
you
by a
mean-
representation.
But what do you mean in Z?
Yeah, I mean in terms of operations you can do on the integers.
Oh, right, yes. So, okay. So you mean like when you take two, like x and y out of Z, then using them, you have an infinitely many ways to get to a certain Q.
Yeah, that's not a problem. The reason that's not a problem is because if you have many representations in your pre-image set, you can just glue them all together using quotient, and then you can just say, oh, we have uniqueness. End of story. The problem is if you try to go from algebraic numbers into transcendental numbers, you will have many representations the other way around. You get it?
So that you can represent a single algebraic number using many transcendental?
Yes, that's logically equivalent, but the crux is many transcendental numbers have the same algebraic representation.
I don't think I get it exactly.
Okay, hold on. Let me try connecting to my PC again so I can actually use the
You know
whiteboard.
what? I'll be right back though. Give me a sec. Ah, shucks. Ah, piss. Ah, shit. Okay, and I am in fact back.
My pretty beans. Okay. So essentially, what I'm trying to say is,
Mm-hmm.
I'm going down here to write. So if you think of the number 0.5, holy shit, why is this writing? Can you hear me? Or
Yeah, now I can.
okay.
I just have found out that I was imposed by a company that sponsors the organization down there. Really? What kind of company, if you can say? Can't I understand? Ash died again. Tragic, painful death.
Because of the beans.
Because of the beans, exactly. Welcome back.
Okay, I don't know why, but my student network is not working, so I'll just try like writing stuff on the phone.
Too much mathematics. They're revoking your maths access. Yeah. But you can see the fun of the hyper-operational stuff, can't you? The thing of ability to reach transcendentals with a finite expression, like that's, like a holy grail theoretical. But even beside that, you can see the appeal, can't you?
Yeah, I can.
It's just fun to find stuff with these operations.
Actually, it might be now that I think about it, but it would have to be very weird. Okay, so we can talk about this if you want, if you have the time.
Yeah, sure.
Oh, so big. Okay. Essentially, my argument was you have, holy shit, oh my god. You have 0.5. I swear to God, what the fuck is going on? Thank goodness it's writing now at least. Right. 0.5. This has a this is a rational number. It has so on and so forth in Z. Right. This is Z cross Z actually. Let's be rigorous. Yeah, it's not possible. Okay. So you can see here rational numbers,
Mm-hmm.
0.5 for example. If you look at Z cross Z, they all generate the rational numbers, right?
Right.
You can just, yeah, this is fine. Like having many representations in your pre-image space, because this is the pre-image space, this is the image space.
Mm-hmm.
Your map is from here to here. Having many representations here is not a problem. If you have multiple representations here, you can just glue them together. You can just say, oh, these two are the same thing, and everything works out properly. The problem that we're going to have here is that um, algebraic numbers have a countable cardinality. Transcendental numbers have an uncountable cardinality, right?
Yeah.
So, okay, if you have any a to the n, right,
Mm-hmm.
n finite, this cannot work simply because of the cardinality argument. Why? Because a to the n is going to be, again, countable, right? So if you try to map a countable space to an uncountable space, if you want a map of the following form, right, and you want this to be surjective, then what's going to happen is you're going to have at least one element A going to, like, I don't know, it's going to map to alpha, it's also going to map to beta, it's also going to map to like gamma, for example, right? It's going to map to multiple elements.
Yeah.
This thing you can't fix, unfortunately, because the sizes of your things are different. You want this to cover the entire space. There's going to be at
So-
least one element that maps to more than one thing. So you have essentially one expression here, right, that's mapping to like three different things here. But then you can't say that these three numbers are equal, right?
So you need.
It doesn't go both ways.
That's a pickle. However, let me have a think. When it comes to Q prime, right? That's the
Yes.
irrational numbers.
Sorry, Q prime is irrational. Yes.
That's the irrational, right?
Yes.
Okay. Can you reach, is omega 3 equivalent to irrational numbers? So that's the point where we have access to roots, the point where we have access to logarithms, and we have access to, well, basically powers of any kind.
I don't think we do, because for square roots, you need an infinite number of square roots to reach pi. So
No. What I'm saying
There
is, pi is in the irrational numbers.
yeah, pi is irrational. Pi is also
Oh goodness,
transcendental.
that's not what I meant then. I thought about, when I said irrational, I meant the set of numbers that
Algebraic
algebraic. Yeah, I'm so sorry. Algebraic numbers is obviously what I meant.
Okay.
Are algebraic numbers countably infinite or uncountably infinite?
They're countably infinite.
Ah, shucks.
Yeah.
That is a pickle. So basically, the problem is that there would have to be a way to cross the threshold of uncountability, which
yeah,
so
you
far there
need to
does not
somehow-
appear to be.
Yeah, that's basically like just set theory. Like you don't even have to go into a hyper operation or like map territory. This is just a question of like, is there a bridge from the countable to the incountable? And no, there in fact is not, unfortunately. These are like two different types of amounts. You can't map from here to here no matter what. Like the only thing it could work, right?
There is one way that I maybe there could be.
The only way is that if you raise this to the power of like countable, right? So you try to express it using countable numbers, then I think that the irrationals and like the real numbers in general are reachable. But like again, you run into the same problem. You have to raise it to the power of to a countable number. So
In that case, what if, in this case, I don't have any rigor for this. This is just me asking what if without like anything behind it. But
that's fine.
we have hyper operations, we have anti operations, we have also, let's call them, I remember I used to call them hypo operations, I think, and then there was a fourth one. Doesn't matter. The point is, there's all arrows point different ways because they're, as I mentioned, you reorder the numbers, right? Let's say that we have, what if there was some kind of operation, or rather a representation that encompasses all combinations of order n or lower. So in this case, when we're talking about this, then when we're talking about this in our omega, then we are not, when for example omega 3, then we're not talking about any number of x to triple arrow x y2. That should be another, that should be 2. We're not talking about this anymore. Only we are talking about every single combination possible. So that would be x2 anti-operated, y2 for example would work, hypo-operated, z1 anti-hypo, I don't know, w2, etc, etc. Because in that case, that all of a sudden gives us an infinite way, like infinitely many combinations of infinitely many numbers, if that makes sense. I don't know if you get what I mean. Would it be enough to get to the a to the countable?
Yeah, I mean, you can do that from the rational numbers as well. Like you can express pi as an infinite square root tower thing.
Yeah, but what I mean in that case is that when we have omega of h, as you know, h is approaching infinity,
Yes.
then in that case we would have not only an countably infinite amount of, well, hopefully but countably infinite amount of values to pick from, but also a countably infinite amount of operations that we can intertwine them with. Would it be enough?
Yeah, then that would work, because countably infinite times countably infinite could potentially be uncountable. Yes.
Okay, so there is hope. I personally genuinely don't think it's possible, but it's a nice hope to have.
I mean, it is though. Like Euler's number e and pi do have representations as like infinite square roots.
Yeah, but you know but the whole point here is that there would be no actual. Well, okay, ideally, it would be that given your hyper operations, they could be defined in such a way that, like, going cross order, that would be the ideal case. So basically, if you could somehow express certain properties of a third order hyperoperation, right, in terms of first order, for example, if you could somehow express that or express it both ways, then there is a potential that you could maybe, I don't know what to call it, collapse infinite sums, for example. So find some kind of high enough order.
Do you want essentially just a structure preserving map? Like going from 1 to 3, it should be preserving some sort of structure at each step that we can go back to 1 somehow, or we can go back to like a large subset of 1 that generates it, or something of that form.
Yes, sort of, yes.
Let me think about that.
I was thinking about it in terms of tensors, because when it comes to tensors, right, if I shouldn't call them tensors, because tensor is like the base idea for it, but just like when it comes to matrix,
Yeah. Just talk about it however you want. I'll parse it. It's fine.
No, okay, yeah, no, because in this case I don't want to be. I'm trying to be also better at mathematics, so I'm trying to be careful with my words. We have a matrix. A matrix basically
Wait, where are you
concerns
writing?
a bit
Oh,
more
there
to
you
the left. Yeah, when matrix basically concerns itself with. That's what gave me the idea, because matrix concerns itself with two operations, addition and multiplication, effectively. Right, matrix transforms, matrix multiplications. You describe them in terms of addition and multiplication.
Uh-huh.
Obviously they all different, map to different r's, etc., etc., but all the maps just function based on multiplication and addition.
Yes.
I was thinking if there was a way to expand them in the way so that they are generalized, which means you have some kind of object. I don't know, let's call it fancy t, because why not? Imagine it fancy with a bunch of loops, because fancy. Mav BB of LaTeX of the T, and then I don't remember if Mav BB is the right package for that. I don't remember. Doesn't matter. Fancy T.
Not bad, but yeah.
Fancy T of n, where that object would function as a sort of matrix, just like matrix is a whole bunch of linear equations collapsed into one.
Yeah.
This one would be the same thing, but instead of for linear expressions, it would be hyper expressions, hyper equations. And the whole point, the tricky bit here is that obviously the most interesting part of linear algebra is the linearity. That's what it's all based about. But since I would need to like find something in hyper operations that would be have a property that's as interesting or as useful or as like translatable as the linearity of linear algebra. Because if
Yeah, so you're essentially looking for a structure to preserve.
exactly, yeah. If there would be some kind of structure to preserve, then you could create this kind of object, and then you could have basically, well, comically enough, some kind of fancy symbol to make up on the spot. I don't know, whatever. There we go. a diamond with a cross in the middle. Basically, then the neat thing about it would be that potentially you could have, this is a fancy F, you could have an equation like this, which would be generalized enough to encompass every single combination of hyperequations. If you catch my drift here. And if there was some kind of structure to preserve, obviously this would be meaningless, right? Because this is effectively kind of like saying that we have a tensor. I'm going to note down the lowercase c to not confuse. It's kind of like saying that you have tensor naught and then tensor multiplication with tensor 1. Like this on its own, without anything surrounding it, is meaningless. It just says, oh, you have two tensors, you multiply them. You don't know anything about tensors, obviously. But in this case, the idea would be that then you could specify and you could basically describe different, obviously different things in different ways, but I mean, yeah, the structure to preserve is definitely what I would be looking for.
Yeah. Well, if you want like some insight into matrix multiplication that might help.
I think
Then-
I think matrix multiplication is. I think linear algebra in general is a good start because over there the linearity is like the guiding theme, and that would give me a pretty good idea of at least what to look out for. I thought that then
Yeah.
tensors would come second because I think I actually might have been mistaken because now we have this talk. I feel like tensor multiplication might not have what I'm looking for.
Yeah, I don't think it will. The thing with matrices, what's so nice about them is we have this group in mathematics. Wait, yeah, okay. We have this group, it's called GL of n. You might have seen it somewhere. Right? So this is essentially the space of all n by n matrices, right? Where the determinant is not equal to 0.
Caper, by the way, just joined. Opened the stream to look for 5 minutes. How you all doing? Got confronted with Oppenheimer Blackboard scene. Hi, the Caper. You see, I have this thing which I would consider to be my mathematical Moby Dick, and I am just infecting Ash with my disease.
Yeah. So the general linear group has these properties. It's the space of all n by n matrices that have determinant non-zero. And what's so nice about them is that this is a group, right? So if you multiply two matrices, two n by n matrices, you get another n by n matrices that also belongs in this group, right? That's why
Yeah.
matrix multiplication is so well defined, and matrix addition as well. If you add two n by n matrices, you also get an n by n. Wait, no, this is actually not true. It's not defined for addition because you can subtract two matrices and get the zero matrix. It's only defined for multiplication then.
So
My bad.
ideally, okay, I think I know what would be a good start then, because as I mentioned, the huge advantage is that the motivation for it was obviously addition multiplication powers. However, in this theory, like the only thing that genuinely guides it is this equation right here. That's like the only thing that's concrete here. I'm noting it in white. There.
Ah, yeah, there you are.
This is like the only equation that actually guides it. However, and once again, this shouldn't be a 2, only it should be an n hat. Or even, yeah, this should be an n hat. Like this, right? This is the equation that guides it. And so ideally, the two things that would be the key. I know that it sounds idiotic for everyone watching. Well, if everyone watching is still keeping up with us, then first of all, that's impressive. Because, well, I can excuse Ash for keeping up with this because Ash is just professionally dealing with this sort of thing on a daily basis. But I do realize that talking about something this abstract is really, really annoying unless you are actively focusing on it. However, I know I'm not saying it's idiotic, but the two things left is to define the x and define the hyperoperation. And I was thinking that, first of all, hyperoperation, I don't like the idea of it starting with addition, because addition is yucky. Or
Yeah,
rather,
sure,
I don't like the fixed points that carry on from there. The fact that not the fixed point identity, sorry. The identity of addition is 0, and identity of multiplication and everything from their point on is a 1. I really don't like that fact. So that's the first thing. And second thing, when defining the x, because I also don't like the idea of x just being just something from z. I don't like that. This feels very limiting. So I'm gonna cross this out. I don't like that idea. Ideally,
Yeah.
well, once
No,
again,
go on.
no, I was gonna just repeat myself. I was gonna say that ideally, I would like the x to be something more of the tenses form, where you would add a new dimension as you carry on the higher operations. To give you more space.
You know, I think this. I have to think a bit about this one.
I mean, you don't need to think too hard, because I first would need to find, as you mentioned, some kind of structure to preserve, and only then I should something. I would need to find the thing that I'm looking for. Basically, I would do not the thing that I'm looking for. Only I would need to figure out what I'm looking for.
Yeah, that's actually a thing that, ironically, that happens a lot when you're learning math. You're like, okay, what do I want here?
But this equation is genuinely, it's like, just like Einstein had the equations of relativity, just like there are the Maxwell's equations, right? Just like there is Schrodinger's equation, this is Makit's. This is the Makit's equation. This is mine. I will one day get to the bottom of it. Funny enough, Kepa, I still have the thing open in the background because I was actually supposed to be working on the website this stream. We got a bit sidetracked.
A bit. Yeah. Well, at least you learned that pinning matrices together is just composition of maps. I think that's a pretty nice insight. To
No,
have.
genuinely, you have helped me out a fair bit because the thinking of it as just combinations of maps. That is genuinely helping out a fair bit, a lot.
That's good then. My job here is done. Served my purpose.
It does mean that when you hold on, no, I do have actually back to the matrices for a second. Out of the fantasy world, back to the real one. You can multiply a vector because obviously dual vector. Is it a dual or a covector? Which one is the covector? Which one is the dual vector? First, really quick tangent.
Vector and dual vector mean the same thing. We just call it covectors. The physicists call it dual vectors.
Oh, cheers! Good to know. All right. So a covector times vector isn't equal to a vector times a covector, right?
Where are you writing this shit? Ah, yeah, there you are.
Very
Yes.
bottom. Yes.
Okay, so yes, it's not, and yes, it is. Question mark? Maybe.
Okay, the problem here
the-
is probably because
thing
I'm
is, like-
coming from the land of like physics, so you know, I imagine it this way, which is probably a problem. Which I don't know if this even makes sense when talking about vectors and covectors, normal ones.
See, this thing here, like if I'm not mistaken, I might be mistaken actually, but if I'm not mistaken, this is what's called an outer product, and I don't know if you're familiar with like geometric algebra or like just differential geometric terms in general, but what this usually means is this is B wedge A.
I am familiar, but I don't like it because I find it too. I don't find it. I find it not general enough. I don't like it.
And this is a matrix, so like
Yeah, I know.
of course they're not equal. This is a scalar.
Yeah, I know. That's what I meant.
Yes.
And so I am familiar, but I genuinely don't like them so much because I find them so annoying. That's because
Bro, that is the best thing that happened to
no, because
linear algebra.
isn't inner product and outer product just matrix multiplication?
Isn't outer product just matrix multiplication? No.
I thought both inner and outer products are just matrix multiplications, except for matrices of size. So, for example, n by 1 and 1 by n, and then 1 by n and n by 1.
Oh my god. You know, it's true, but you shouldn't. But just because something is a matrix doesn't mean you have to force it to be a matrix. Just because something is a tensor, you don't have to force it to be a tensor.
Okay. I just can't bear to remember all the multiplications. I just want to remember one multiplication. Wedge, outer product. That honestly, I will attribute a significant portion of it to Lemon because Lemon has been mentioning so many different multiplications that or products that I'm just sick of them. I'm sick of them till the end of my days, I think.
Yeah, you're sick of them because like nobody's properly introduced you to them. If somebody properly introduced them, you would, for example, wedge product is something that you'd immediately fall in love with because of how good it is, how nice it is. We can go over it right now if you want, but like that would take a lot of time.
Maybe I should think of it in terms of maps actually. What if? But I would need to not do it with fields at all. That's a pickle.
What do you mean fields?
Well, I'm thinking back to the hyperoperational, which is
Okay.
Yeah, sorry about that. It's been on my mind for literal years. Okay, I cannot. I don't have the ability to get anywhere with it, but it genuinely has been on my mind for years.
One day you might have a breakthrough. I mean,
I hope. It is my Moby Dick. It really is. But okay, let's notation wise. Oh, notation wise, by the way, I use hats here to represent. Let's call them constants. So basically,
where are you writing?
oh, I'm not writing anywhere. I'm just talking about my
Okay.
hyper-operational. Yeah, I'm using
yeah.
hats to represent like constants, basically. And the reason why I'm using
Okay.
hats is because that was before I knew enough about physics to even know what like operators are exactly.
Yeah.
So that's how while back ago I started this. I would like to mention. It was. I should move on.
I mean, if you look for a bit, you can probably find a conclusive yes or no to your question because your question like sounds interesting enough that I wouldn't be surprised if some mathematician before you just
Okay,
you
sure.
know solved it already.
Well, I think you will need to speak in order for the Capri Sun to actually rotate. Unfortunately, you know what's funny? I still have the Capri Sun, by the way. I still have it.
Yo,
Yeah.
go on stream.
Let me take it. Unfortunately my camera is my camera is fine, but the
Oh, don't bother about it.
HDMI. I recognize that picture. Hold on, I'm gonna send a picture of Caper in the voice chat.
I guess squeezed caper dry that day.
The squeezed Caper picture is comical. There we go. Here.
Perfect. Cheers.
This be a Caper.
Oh my God, Remco! Since when were you here?
Hi there, Remco. How you doing? Ah, you missed out on Ash teaching me the intuition behind matrix multiplication. Okay, from what I see, where inner product is a dot product, outer product is a tensor. I also wonder if you could use the conjective properties to find it. That's what I'm about. Search for the serial double, yeah? There's no for the weak-willed. Do you want the physics interpretation too? No, I have a decent. To be fair, I know how you would apply it in quantum mechanics, which is where I got it from. I just didn't have a good mathematical intuition for it, which, well, this is my mathematical intuition for it now. So basically, like, the proper word won't be combinations of maps, will it? What would be the proper word for this? For matrix multiplications as a whole bunch of maps.
Matrix multiplication has a whole bunch of maps, just linear maps between vector spaces.
Yeah, but what would be the proper word? Would it be combination of linear maps?
Composition of linear maps.
Composition. There we go. Cheers.
Like if you chain one after it.
In my defense, I am trying to get better at mathematics as well.
No, it's perfect. Like trust me, a year ago I was horrible.
No, but that's what I'm saying. That the thing is, I've been badly influenced by Remco, and I am very improper with my
Why I
decision.
learned maths before the physics. The physicists couldn't corrupt me.
Genuinely, I love the bit of the video.
Algebra, other quantum mechanics, in my opinion.
I love
I
this.
mean, if quantum mechanics isn't enough to justify linear algebra, that's crazy. But also, linear algebra is used in all sorts of computer graphics computations known to mankind.
Yeah.
So, you know, if you don't like playing your, what's a good game right now? GTA 6 isn't out.
Not
But
even
anyway,
games.
if you like good graphics in your games, then linear algebra is pretty important.
If you like graphics, period, there isn't a single kind of graphics that doesn't utilize linear algebra, because obviously, I'm thinking
Yeah.
if there are how many things there are outside of graphics that utilize linear algebra, because funny enough, despite vectors being the bread and butter of all of computer science, um, linear algebra isn't. I'm pretty certain cryptography uses a fair bit of linear algebra as well.
I'm not that acquainted with the computer scientists, unfortunately, so I don't know.
I feel like I actually don't know if you would like it, because it's a very different vibe from physics. Obviously, it is applied math. I feel like the nice thing about it is when computer scientists apply mathematics, they are very correct about it and proper. The downside is that they don't ever use anything abstract. So you will find more you will find more creative mathematics in physics, but you will find it more properly applied in computer science. Let me.
Yeah.
So for example, well, I don't think you would have many geometric things, for example, in computer science. You would have topology, certainly. Now, I mean, certainly you could find some geometric, just not that many.
I don't fucking know. People use category theory in computer science. It so scares me. Like, holy fucking shit. How is category theory even applicable? Like,
Well, I imagine
crazy
it's
to me.
because when it comes to certain, it's easier to operate with things in category theory.
I don't know. I have no fucking idea, and I don't, and I'm definitely not qualified to talk about this.
Well, the thing is, when you have a notion of a set, for example, right?
Yeah.
You, from a computer science point of view, it is useful to think of terms that this set might. It's useful to think of places where the set might get you. So, for example, topology, right? Extremely useful in computer science. However, set on its own is absolutely and utterly useless.
How the
Because
fuck do you use topologies in computer science? That's also crazy.
that's simple. It's because really often you just don't care about distance. You use topologies almost exclusively as a metric space without the metric. You use it as a
Yeah.
metric space without the notion of distance. That's so. For example, I can give you a really easy one. Networking. When you have networking, you have a whole bunch of
Like,
points
kind of
connected.
Okay.
Yeah, and you care about the ways in which they are connected, but you don't care about the distances
no, it
between them.
makes sense.
Yeah.
I got it. Thank you. Holy shit.
Topology
Yeah, okay, that makes
is genuinely crazy common.
I mean,
Okay, but I would just like to mention the
personally,
challenges. Go on.
I think it's more graph theory than topology, but
Well, no, there are also topological things. Hold on, give me half a second to think of something. What was I'm certain. Let me think of where topology has. Well, would maze solving be topology? It could be. Maybe maze.
anyways,
Maybe maze solvings could be also topology related. I am certain that topology is used a shit ton.
I don't doubt you because I have no idea.
Hold on. Because this is gonna drive me crazy. I am at the tip of my tongue. I have so many examples, I can't think of a single one. Topology in computer science. Computational.
Coffee mug is
Coffee mug is a donut. Well, that's a very graphical example. That's not something you would actually do in computer science.
That's also not something that you would do in topology. I mean, funny enough, that's not even a topology thing. I think that's more of a homotopy thing. Yeah.
Algorithmic knot theory. Hell yeah, knot theory. Finally making a comeback. Topology.
Algebraic topology, which is just homotopy theory, which is bad. I don't like.
topological sorting, apparently. Anything related with trees, if I'm not mistaken, was topological. There's most
I
things.
mean, yeah, I can imagine.
This is driving me nuts because genuinely I've seen topology so often.
Because if you have a
mentioned.
point, then a neighborhood of the point would just be the points that are connected to it. So, I mean, if that's not it, then I'm sorry, I'm completely lost.
I mean, no, yeah, it is certainly. But I'm just trying to think of a better example where it would have been, it would be a bit more continuous. Let's call it.
Oh yes, I do like my continuous topologies. Discrete topologies suck.
The one thing that surprised me is how game theory is used in electrical engineering. I don't like the term game theory. I genuinely dislike it. Because game theory isn't really a field of mathematics, it's just sections of a couple of fields. I remember the while back ago I was bothered by it, and someone explained to me that like game theory is concerned when you have an intelligent system, and when you're talking about the actions of that intelligent system. But that on its own is just game theory is so many different fields of math just picked away and clumped together. I don't like to consider game theory as a field of maths. It bothers me to think of it as a field of maths. It sounds like stats. No, because in game theory, basically the whole defining feature of game theory is that you have something in your system that has different options it can take, and then it has some kind of rule set for which option to pick. And depending on the circumstances it's in, it will pick a different action. And the whole point is that when you grab them together, then their interactions will change because they're dependent on the environment. And the whole point there is that you can't really solve it normally because of this. Yada yada yada.
Game theory is just sibling rivalry, in my opinion. Like, how do you one up your sibling?
After watching your streams, I found my touchpad on it realize I keep gesturing ugly. A plastic cover, also called keyboard bezel assembly.
Anyway, I'm gonna dip for a second to cook some rice because my beans are now done.
I think I'm gonna dip permanently actually because I'm not getting work done. I need to
Yeah,
finish the.
I didn't get any work done either.
Oh, I mean no, I have been rendering the entire time in the background. Don't worry. It's just that I was supposed to be not only working on the video but also finish up the system of resilience for the website. We will actually chat about that later. Remco, are you still watching? Because I will also need to chat about that with you. I would also like with Caper, but unfortunately that might not be possible. Because I have plots and schemes and plans and such.
And such.
Okay. Well, in that case, thank you everyone so much for watching and have a great day. Bye.